like to everyone is here. We're going to be talking about integrating HOP principles with incident analysis with my good friend Rick Foote today. And as a reminder, we're all here as part of the co-learning webinar series, which there will be some changes coming up, and Jessica will help me at the end of this presentation by putting in those changes in chat, and you all can see what kind of things we're conjuring up for the next year. So let's go ahead and just give a few more minutes. And I like how the AI comes up automatically now and asks you, would you like me to play music? Depends on what kind of music you're going to play.
Exactly.
Okay, I'm going to go ahead and get started in the interest of respecting folks' time. And I know that I want to do the introduction for Rick and then get him on his way, because you're here to hear him and not me. Okay, our presentation today is on integrating HOP principles with incident analysis. And I can relate to this in the sense that this is what I do for a living in root cause analysis. So I'm very interested in the topic. Let me give you a little bit of background on Rick. Rick is the owner of Compass Performance Improvement and serves as senior consultant with Foote, which many of you know as Fisher Improvement Technologies. Rick has over 30 years of experience as a team leader and mentor for incident analysis teams spanning multiple industries, primarily high hazard and power generation, distribution and transmission, refining, and manufacturing. Rick's taught incident courses on 3 continents and served as the lead instructor for incident analysis courses hosted by the IAEA, which for the rest of us is the International Atomic Energy Agency. He was among the first to integrate HOP principles with incident analysis approaches and has successfully managed the Corrective Action Program for major corporations. We will thank Rick in advance for his service. He's a veteran of the U.S. Navy submarine service and resides in Charleston, South Carolina. So with that, I will turn it over to the person we're here to listen to and thank him for his time and his service and support for the community here at the Community of Human and Organizational Learning. It is your turn.
Thank you, Bob. I appreciate that. Just a little bit more about my background. The very first formal root cause analysis I ever did was back in the commercial nuclear power industry, where I got my start. And we had a reactor over power incident. So we exceeded our licensed power limit by 2%, which is never a good thing. So I didn't get this little bite-sized one to get started with. I got this big regulatory issue. I get the call. I just gotten trained on being a root cause analyst. I get the call that we've had this incident and I needed to show up at a certain conference room. And I go there and the entire reactor operator crew is all outside the door waiting their turn to be interviewed. I go in the conference room. I don't know what has happened until I'm sitting in the interviews. Let's just say it was a disaster. That was kind of the worst root cause analysis experience I've ever participated in. Wasn't the team lead on that, just learning, but my goodness, I learned a lot more ways not to do it than to do it. Between that start and the last one that I actually was on the ground supporting an organization with, which was a contact in a substation of a crane with an overhead high voltage line, 26,000 amps conveyed through the ground on the crane to the grounding mat on the substation. And I got the opportunity to interview the luckiest man alive. I think it's 0.01 amp that will kill you, and 26,000 amps conveyed to ground. So everything worked. All the barriers worked as they're supposed to. And you're talking to someone who knows that they shouldn't be there. And so in between there, hundreds of different analyses that I've been involved in some capacity. It's just a fascinating, interesting life, a lot of sad things that you see. But But when it comes to incidents, do you ever feel like this? It's Groundhog Day. And, many of us have seen this movie with Bill Murray, and he's reporter Phil Collins. He's got to cover Groundhog Day. And he's kind of an arrogant, nasty kind of person. And he gets an opportunity to continue to repeat Groundhog Day until he gets it right finally. That's the whole premise of the movie. Love the movie. But do you ever feel like that when it comes to incidents at your company, that you're just reliving the same day over and over again? But one difference is, unlike Phil Collins in Groundhog Day, he got a clean slate every day. It erased the consequences of the previous day. And we don't often get that. We don't get a fresh start. The consequences that we experience from the last incident could be an injury, could be an economic impact to your company, reliability issue affecting your customers, product quality issue. They're still out there, and you're still affecting people and lives with that. So we don't get to erase the bad things. So how do we break the cycle? How do we get out of this repeat event mode?
Rick?
And it really comes, go ahead.
Can I quickly cover a base that I didn't cover? Is that in terms of questions, as we go through this, you should see your chat on the toolbar. Feel free to go ahead and chat in at any time, and I will politely interrupt Rick and address it at the time he's talking about that topic. And if you're really passionate about it, we can just unmute you and you can go ahead and talk to him directly. And there will be a Q&A at the end. So that was my I missed it. I covered it. Thanks.
Oh, and great thought, Bob, because I also mentioned that everything in this presentation will be made available to you through the learning opportunities. So you'll have access to all of this. So how do you break the cycle? Well, it's really about hop integration. Okay, so hop integration increases the odds we're going to get to the right answers. Now, the whole reason that we do any kind of incident analysis is to increase the probability of getting to the right answer before we act. When things go wrong in our daily lives at work, we can typically say, hey, this caused it, and be right with some frequency, because we know we are people, we know our processes, we know our components, everything. And so we can be right with some frequency. But when the actual or potential significance of the event goes up, what we want to do is increase the odds that we get to the right answer before we act, because we can't afford to be wrong. And so what we're doing is upping the ante, increasing the probability of getting to the right answer before we act with corrective actions. Hop integration actually takes it a step further. It further increases the probability that you're going to get to the right answer. And that's pretty important, because if we don't, we're generally going to fix the wrong thing. So if we arrive at the wrong conclusions as to what happened, how it happened, and why it happened, our fixes are typically going to miss the mark. We could get lucky and, independent of a good analysis, arrive at a solution set that actually does something, but that's just being lucky. More often than not, if we reach the wrong conclusions as to really what's involved in this event, our fixes will miss the mark. So what we've done is we've done some type of change to how the work is done, how the equipment is operated, its design, etc., that had nothing to do with the original problem. So the risk profile associated with the original problem stays constant. But what we've done is we've introduced a change, and people don't like change. And when we introduce a change in how things are done, we can at least temporarily increase the human error rate of those performing the task until they get used to it. Now, if the change makes the process inherently more complex, what we could do is provide more opportunities for human error and actually increase the human error rate going forward. Same thing with equipment. Let's say that as a corrective action from this incident, we go ahead and implement a design change. Whenever you do a design change in terms of how the equipment is operating and design and its components and materials, we can temporarily increase the error rate. Now, think about never buy a first-year car, right? And don't you think that the automobile manufacturers, design people, they tried to anticipate all the downsides, everything that could go wrong with this design change, but they don't get them all. And so you want to avoid that first year car until they get the bugs worked out. And so a design change to equipment can at least temporarily increase the failure rate of that equipment until we get the bugs worked out. But if the change makes it inherently more complex, there's more moving parts, there's more inputs, there's more things that can go wrong, we can at least or permanently increase the failure rate of that particular piece of equipment. So meanwhile, we didn't address the real issue, is risk profile stays constant. What we've done is increased risk, at least temporarily, on the things that we touched that had nothing to do with the incident. So bad cause analysis and bad corrective actions, it's not some benign thing that, it's no harm, no foul. No, we can do a lot of harm to our companies by getting it wrong. We got to fix the right issues. And so HOP integration will help increase the probability that we get to the right answers. And so we're trying to break that cycle and make things a lot better. So without HOP integration, it doesn't matter what incident analysis methods you use. If it's not considering HOP, if HOP isn't fed into it, you're feeding it wrong data. And so this wrong data is going to come in, come out, garbage in, garbage out, regardless of what you're using. You need to figure HOP into the whole process and how you're thinking. It drives the questions that you might ask. It drives when you're satisfied that you've reached something that you could consider causal for an event. So without it, garbage in, garbage out. Well, HOP principles, and I have a number of them listed here, and there's a lot more. They're not just theoretical concepts like fairy tales. These are real. They affect things. And in my line of work, where I'm doing incident analysis as my career, I see these things at work. I see them happen. They're real. They're living. And so here's kind of a case in point. This is a picture on the left that depicts the task-based systems that's based on W. Edwards Deming's second principle of quality. And what he says is when bad things happen, that at least 90% of the time, it's systemically driven. It's not just Fred or Amy zigging instead of zagging. There's a systemic issue that is driving that act or decision. And the model that we've developed here at Fisher that's based to kind of flesh out Deming's second principle of quality is we have the person in the center, and they're surrounded by a system of 6 building blocks. You have equipment and tooling, you have people, you have programs and processes. Programs are kind of the high-level descriptions of what you do, like a PM program, preventive maintenance program. And the processes are really the details and procedures of how you do it. So maybe the preventive maintenance tasks themselves. Then the environment in which the work is performed, and then the organizational structure, funding, roles, responsibilities. And that these 6 building blocks, they interact with one another, and they interact with the people in the system, and the people interact with the system. And so this is a dynamic system moving along. So here's an example. This is an analysis I was involved in. This resulted in a significant life-altering injury. And so if you see the picture in the center here, you'll see laying towards you a high voltage disconnect. And in the back, you'll see the structure from which that high voltage disconnect has been lifted from. And you'll see the other 2 phases still on the structure in the back. So the task was they would go ahead and use this crane in the right, and they would go ahead with a 4-sling apparatus. So slings attached to the hook, and then shackles on each end attached to the base of the disconnect in 4 locations. They go up there and lift it off and lay it on this dunnage, this wooden cribbing. And so what was supposed to happen is that once it's laid down and set down on the cribbing, that they install lag bolts on either side through the frame into the wood dunnage. Then they're going to disconnect the shackles from the frame and then lift the rigging apparatus free and then go get the next one and set it on alongside of it. In this particular case, the crane, when they were lifting away, the shackles caught on the frame and started tilting it toward the right on that right picture. At the time this occurred, there was one individual standing on the left side of the disconnect, and there were 3 on the right side. When this thing started falling, 2 on the right side of the disconnect were able to evade. 1 fell backwards, and the double glass insulators portion of that fell on their legs. And again, significant life altering injury. Let's say the person will never be whole again. Okay. The crew tried to lift the disconnect off the person, could not. It weighed 1,800 pounds. They repositioned the slings on the crossbar and had to use the crane to lift the sling off of that. So that's the event. So here's some issues. The crane operator, when it was time for him to lift the hook and lift the 4 slings with the shackles attached, he was concerned because he saw the crew wasn't holding the slings away from the disconnect. And he'd had cases in the past where a disconnected shackle had caught on the load. He was very concerned, and he thought about getting out of his cab and saying something to the crew to warn them, asking them to hold the slings away. But he did not. And the reason he did not was because he had done so the previous day and been ridiculed. He told them, hold those away, and essentially been said, stay in your cab. We got this. Don't tell us how to do our job. The crew leader, who he was working for as staff augmentation, also laughed at him and said, we got this. Don't worry about this. So he thought about saying something, but he chose not to because of what had happened. So you see in the drawing over on the left, we have a people-to-people interaction that affected the actions and decisions of the crane operator. But there's a programmatic issue as well. The crane operator, even though he's in charge of basically operating the motive force for the lift, he is not in charge of the lift. He's not in charge. The crew leader is in charge. So you have a programmatic issue that affecting the people that they're working with, and also the crane operator in the center, that is affecting the where you don't really feel that you can stop this. You know, we talk about work stop authority, but sometimes you don't feel like you really are enabled to do it. So you got a programmatic issue that crane operators are not in charge of the lift. Some other issues that were a factor in this particular event, if you look in the right photo, in the bottom left corner in the right photo on a map, you'll see the lag bolts that were supposed to be installed through the frame into the dunnage. And they're laying there on either side. They did not get installed. What had happened is the worker standing on the left side of the disconnect in that right photograph, he was going to install the lag bolts like he was supposed to, but he saw a pair of operators or electricians descending in a bucket. And he's the new guy. And he's been told that if you're the new guy, you got to serve the people that are more experienced than you. And no one should ever come down in a bucket. You need to get them what they need. So when he sees the bucket descending to the ground, he gets distracted, asks what they need, and forgets to install the lag bolts to secure the frame to the dunnage. Another thing in terms of a weakness here, this same event had happened less than a month before at another substation where 4 disconnects had toppled into one another. That information had not been communicated. They didn't have a effective program for communicating lessons learned. And so the job itself could have been done with people standing on either end of the disconnect. They could have disconnected the shackles from there where no one is in the line of fire. But that information didn't make it out due to a programmatic weakness there. And so just showing you there's a lot of these these events that I see, that these things actually come to life. We see the weaknesses in the task-based system on the left. We also see Sidney Decker's principle: people do what they do at the time they do it for reasons that make sense to them at the time. Made total sense for that crane operator in their mind to not get out and intervene. Made total sense for that worker to react when he saw a bucket coming down to the ground. And so people, we have to consider them in the context of the system in which they operate. So when you have systemic drivers and traps and they're present, the table is already set for the incident to occur. You just have to change a variable or two. And I see this time and time again when I go in and ask to come into a client's facility and lead a team, how close we came in the past, but there was just one or two variables that were different. And nothing happened for a long, long time until it does. Now, when we think of the system, and Bob, I'm going fast. I don't know if there's been any questions yet. We good?
All right. Yes, we're all good.
Okay. Now, when we think about this systemic issue, the system is envisioned by W. Edwards Deming. We often are thinking really in regards to the people involved in the incident. They're in this system that surrounds them and weaknesses in the system. But we also have to think about the system applying to us in our daily lives and as members of an incident analysis team. If you think about as an individual member, there's different things that could impact you and your effectiveness as an individual member. Could have equipment issues associated with the analysis. Other people are trying to influence it. Your program and processes for doing an incident analysis are not very strong because they don't integrate HOP. The environment that you're working in, it can be an issue in terms of you don't have privacy, they have to keep moving one room to the other. And then the organization may not be very supportive of the work that you're doing. They may not allow people to be dedicated to or to keep yanking them off for other things. So the individual performers on an incident analysis team also have a system they're working through and can be, in fact, bothered by that. And so what we want to do as organizations is try to provide the best possible system for the analysts to work under. So here's 5 keys to having great success doing incident analysis, and they all have to do with HOP. The first and most important is that the senior leadership of your organization has to be grounded in HOP principles, not just know about them, but to be believing in them, living them. They have to really have a grounding in human organizational performance principles. The second is that the participants in the incident analysis themselves must be educated when it comes to HOP. Also, HOP has to be integrated with the methodology itself in terms of your processes that you're using. They're driving you to consider human and organizational performance issues. It also has to be integrated with the solution identification. Not all corrective actions are created equal when it comes to effectiveness. So we have to integrate and think about what truly will fix this going forward, what truly will change behaviors. And then finally, HOP has to be integrated with the processes you use to review and approve the results of your incident analyses. And so we're going to cover all 5 of these elements. First one, again, most important one, is that the senior leaders themselves have to be grounded, firmly grounded, rooted in HOP. Because if they're not going to seek out, accept, or even embrace, is what we want, embrace that ugly baby. We want the leadership to desire to improve, to accept and embrace the worst results that could possibly come from the analysis. And because if they don't have this, they're not grounded. They're not going to recognize for themselves the need to have HOP-centered incident analysis processes to manage their own human tendencies to place blame, which one of the HOP principles, blame fixes nothing. We're going to come back and talk about this one in a minute. Also, to dedicate the resources necessary to get to the real issues and have the patience to allow the process to work, the time it takes to get a thorough analysis done to get to those real issues.
Rick, if I may, I do have a chat question.
Sure.
And I will ask Rosina, it is question time. And if you'd like to unmute, you can go ahead and ask any question you'd like.
Thank you, Bob. Yes, Rick. So I do work in HOP here at Caterpillar, and what we find is complicated is whether it's with any group, but especially with leadership, is to, when you said the time to tell them that their baby's ugly and have them truly embrace this approach. While it's logical that we all want to increase our safety, the thing is, there is oftentimes a lot of resistance and an unwillingness to take accountability. So any tips or recommendations you have for perhaps whether we're dealing with others or dealing with our own teams, how can we ensure that we can have everyone be on board with what we can improve? Or do you often find resistance and massage that until they become accustomed to this approach is the best approach forward, the most effective one?
I think it really starts with senior leader education, and so that there's recognition on their part that the real answers, the vast majority of the time, are going to rest with systemic issues, and that they're anticipating and waiting for that. And I have this little last bit on this slide. It says, "Stop bringing me the 1%." Okay, so what we mean by that is that per Deming's second principle of quality, that 90% of the time that the actions or decisions that are consequential in an event are driven by organizational issues. Okay, 10% is what Deming says. Now, in practice, Deming was pretty conservative. And if you haven't heard of Deming, he's the father of quality control, statistical sampling, statistical process control, all born on Deming's theories. And again, he says 10% of the time, only 10% of the time can it be isolated to that person's behavior and not be systemically driven. So, and in practice, in 33 years of doing this, what I found is that Deming's was being conservative, like most principles are. And what I've seen is about maybe 1% to 2% of the time when you have an individual whose action or decision proved consequential in a significant event, is it truly isolated to them? So it's pretty rare. It's a pretty rare bird, and getting understanding of that. The 1% comes from when it comes to, let's say we go with Deming's 10%. Of those 10% that what Deming is saying could be non-systemically driven, 90% of those, so 9 out of 10, are errors. And errors are cases where the individual, they are trying to comply with the rule, or they're simply unaware a rule exists that applies to the situation, so they don't do something. Only 10% is of those isolated ones are violations, conscious deviations, where the individual knows there's a rule that applies to the situation and makes a conscious decision to do it another way. So if you're looking at only 90% are really isolated errors and violations, and only 1% of all actions and omissions that are going to create consequential events are isolated violations, conscious deviations. It's a really rare bird. The "stop bringing me the 1% came from a senior leader education system where the CEO of the company, after being taught these principles, said, "How come you guys are always bringing me the 1%? It's always an isolated violation. Conscious deviation, no systemic drivers. It's not statistically possible. This knowledge and understanding changed the entire mindset of the company, and it starts with senior leaders. Them understanding how truly rare it is to have an isolated error and violation, have the appetite to go when bad things happen, to have the patience to be looking for systemic issues that explain that behavior, that action or omission. Satisfy yourselves there weren't any after a thorough analysis before you ever arrive back at the thought that it was an isolated error or violation. So I'll have to circle back with you and say, did I answer the question in terms of the awareness where they can see it for themselves and it makes sense to them is really where things change for your organization. Did that answer your question? I hope I did.
Well, thank you, Rick. Yes, I'm aware that if they can understand that, it's just a lot of, I guess it borders perhaps more on taking accountability and understanding what part of the system they can influence and control. Because yes, once they understand it's a system, there still tends to be some deflection as to not my department kind of behavior. So thank you.
Well, and the senior leaders are going to have to drive that too, ownership. And, you know, this dovetails into the issue of blame. It's human nature to place blame. We all do that, to assign fault. And it's very easy post-incident because very early on, we're going to know that somebody zigged instead of zagged. And we'll know that up front. And if they had only zagged, we wouldn't be here. And so we can lock on to that and not want to go any deeper. One is that feeds that is just our blame culture. We like to place blame. And then that's easy and it sounds pretty quick. All I got to do is fix Tony and we're good. And also it's a lot less intrusive to say this individual's behavior is an anomaly that cannot be explained by our systems. That's nice, as opposed to saying, I got all kinds of systemic issues that this is a symptom of. And I'm not only worried about Tony, I'm worried about Amy doing and falling into the same traps. It's a lot less palatable. And so the culture of a continuous improvement culture is that you want to know the real answers, no matter how painful they are, and you don't have the punishment culture. And so people really are looking for the answers that can result in systemic fixes that are going to win you long term, win it over for you.
John, I noticed you made a statement in the chat and you unmuted. Did you have a follow-up?
You there? Can you hear me?
Yes.
Yes.
Okay, I think your presentation's spot on, man. I worked nuclear and fossil generation, and there was a big difference in culture between the two. My 30 years in nuclear, we definitely wanted to get to the root cause, and 3 Mile Island really was the event that turned around the whole industry, as you know and I know.
Mm-hmm.
But I think in the real world, I see there are real root causes. People like us and the Chemical Safety Board that want to get to the real root cause. Then there are legal root causes, and I've been part of that too, where legal people get involved and they don't want you involved with the investigation. So it's real, like you said, it's really up to senior leadership. I can't agree with you more. They need to be involved, highly involved, and grounded. Good point.
Okay. I appreciate that. And I think if you don't have that, it's the tail wagging the dog. What's important to your most senior leader is going to be important to your mid-level manager, is going to be important all the way down. And let's talk, this is a good opportunity to talk briefly about about blame. It really doesn't fix anything. If you think about Deming's principle, 90% of the actions or omissions that are consequential are errors, which means the person either didn't know there was a rule or they tried to comply and they made a mistake while doing so. When you talk about sanctioning individuals and holding individuals accountable for errors, you have to think, how effective is it to have some type of sanctioning that's essentially don't ever do it again if they never intended to do it in the first place? Even for conscious deviations, those other 10%, if those 90% of those conscious deviations are also systemically driven, there's issues in the system that make it make sense to consciously deviate. If you don't fix those systemic issues, and all you do is punish the individual, you still have the systemic issues driving behaviors of others. And so it really isn't, sanctioning individuals just is really not something we'd ever do in part of an analysis as part of a corrective action plan.
Okay. Rick, in the interest of time, and if there are questions that want to get in deeper, we can always approach Rick afterwards for one-on-one conversations. But I know that you're on key point number 1, and you have 4 more to go.
Yeah, we'll keep going then. But great questions, thank you. Okay, the key number 2 is that the participants themselves, they need to be educated in HOP, and so you want to educate team leads and individual analysts on HOP principles. It's a nice thing if everybody on the team actually has some background in HOP, but if not, then the second bullet is during the initial team briefing, when you get your subject matter experts in there, that you're educating them and you're bringing up the Deming principle and Decker principles and showing them how unusual it is to have an isolated error violation, that we're looking at systems, we're looking at making sure that they're not systemically driven. So it's an education the team's got to have also. And when we do our workshops at Fisher for incident analysis, we start off multiple hours of HOP principles and how they integrate into the process itself, just so that everybody is grounded in those. And then key 3 is that HOP has to be integrated into the methodology itself. And so we have a process what we use called gap analysis. And so we have our problem statement, what we're trying to solve. And we say, okay, where is our baseline? Where do we stand regarding the facts of the information we already have available to us? What do we consider our baseline facts that we can trust, that no further verification, validation is needed? We get that baseline, which is usually a small subset of what is known. And then we start brainstorming. What else as a team do we think we're going to have to learn in order to solve this problem statement, determine how and why it happened? We'll go and use this task-based system and with models, which are traps, to try to make us think about questions, things that we should look into in order to rule out systemic issues, as well as traps like fatigue, et cetera. So it prompts us. Each question the team comes up with goes on its own sticky. Those stickies are aligned with the best possible source of the information. And so then when you're done with this, every question that the team has consensus has value in pursuing to solve that problem state and gets aligned with the best source or sources. And so now we know when we're going to interview the operator, we've got 3 things we want to ask. If we're going to go to the site, there's 4 things we're looking for. And then we make our assignments and go. But we're using that task-based system and with model integrated into this to get our actions. And people go work their actions, they come together, they share information. We may find out that one piece of information we learn helps us realize there's 2 more things we need to do. We can create new questions, align those with the best sources, and you continue on. And one of the signs for me that we're ready to move out of this particular fact-finding phase is that we don't have any noteworthy gaps left. The interviewing practice shared in our Fisher workshops, they try to increase the probability of obtaining accurate account of the individual's recollections. And that's really what you're going for, is what do they recall? Information from individuals is extremely fragile. Individuals are only going to remember about 75 to 80% accuracy following an incident if they are warned that something's going to happen, and then it happens right after that, and they're looking at the right location, and it's got great view and lighting, and they're not distracted by others or other things, and they write down their recollections immediately, and that never happens. And so we're dealing with much less than 75, 80% accuracy in these analyses. But what we're trying to do with our interviewing practices is increase the odds of getting what is left. And we do that in a few ways of making them as comfortable as we can by relating to them rather than interrogating them. We're not going to sit across the table from them. We're going to share a corner of the table. We're just going to have a cordial discussion, and as much as possible, turn an uncomfortable, inherently unfun situation of being interviewed post-incident and turning it into a couple people having a conversation with a shared goal of it not happening again. And so our practices that we go are designed to do this. They also help us reduce the potential for the interviewees to influence each other's recollection. We want to interview them one at a time. And then also minimize potential that we as the team, we bias the results by asking leading questions that suggest a preferred answer. Process is awful complex, don't you think? Finishing their sentences, indicating agreement or disagreement with their statements, or inaccurately capturing what they said. And then asking probing questions using the TEDS approach. Tell me, explain to me, describe to me, show me, to explore the reasons why actions and decisions that prove consequential, that they made sense to them, because they did at the time, looking for those systemic drivers and traps. The tools themselves that we use, you can see our list of tools that we use at Fisher. They're nothing earth-shattering. These are pretty common industry tools, but what we've done is we try to simplify them to where they deliver without the fluff. And so they work for us instead of us working for them. So we try to hop the tools themselves. One of the tools that we will always use when we have a human action that was consequential in an incident is to do a task analysis where you're comparing how the task was supposed to be done versus how it was actually done at the time of the incident. So in doing this, we're not only looking at deltas between how the task was laid out and what the person did, we're also looking for weaknesses in the methodology itself, that it's vague, that there's more than two action steps in the same step, that there's if-then criteria that could have been confusing. If you have if-then criteria in your operating procedures, you are 11 times more likely to have a bad result than if you just told people what to do, because they are having to diagnose, have I met the entry conditions? And then they have to respond appropriately. And we see many, many events where it is not clear to them that they've met that criteria, or they think they have and they really haven't, and then they do something that creates a problem. So we're looking for issues with the procedures, with the tooling assigned that could explain what happened in this event. Then the barrier analysis is a very well-known tool. What you're doing, you're taking the theoretical Swiss cheese model and you're actually building it for this particular event. What was my threat? What was my target? Barriers that were present that did not work and why? Ones that were present worked. Ones that were missing that could have made a difference. And you're also considering barriers, layers of Swiss cheese, after the target, those like your emergency response protocols, emergency lighting, that are for detection, mitigation of the results, effect, duration, and severity of it. And so, great tool. We have a tool called Organization Programmatic Analysis, and it helps us prompts consideration of this 17 most common systemic drivers related to organizational programs management. So it makes you think about it, provide a basis for conclusions for ruling it in or ruling it out. The question 18 is just, did we think of something? Is there something else we didn't think about? But you got to document your results and think about it. Common factors assessment is a tool for multi-incident analyses. It differs a little from common cause analysis in that we're actually looking at other elements besides just causes. Type of event, you'll notice the performance mode. We're looking at what's the performance mode involved in that particular incident in this data set. It's rule-based, skill-based, knowledge-based, error traps that were present and called out, failed missing barriers. So we're not just looking at causal level, we're looking at it across the board, looking for commonality in issues, but again, using those traps, barriers, performance modes. And then we recommend everybody create a logic diagram that firmly establishes that cause and effect relationship between the incident, its causal factors, and the contributing factors. If you cannot draw a logic diagram that shows a clear connection, fact-based connection, all the way from consequence down to causes and contributors, then you got no business approaching management to get them to spend a lot of money. If it doesn't make sense, you got to quit, right? So we, by making you do a logic diagram, helps you avoid jumps in logic. You could have landed in the wrong spot and have errant conclusions. Help you recognize that complex set of interactions that it took to get to this event, this day, this way, this bad, how everything worked together. And it's a great tool for communicating the basis for your team's conclusion to management, because they can see your work. This is what you view as logical that led you to these conclusions, and they can follow along. And as a management reviewer of many, many root cause analysis reports, including some of the ones in the nuclear industry, 100 pages, it's like the very first place that I would go was their logic diagram. Because if there were breaks in the logic, and I said, why did this happen? Because of this. And if it doesn't make sense, I don't need to read that report, because it's error carried forward. They need to fix that. And so it's a lot less subjective as a management reviewer to say, there's a break in your logic here, as opposed to, I'm not comfortable, because at least I have a basis for that conclusion. But when you're constructing this logic diagram, you want to, on each branch, and notice the branches, on each branch, you want to pursue asking and answering why until one of the following occurs on each individual branch. The first one is if that branch is explaining a human act that affected the outcome of the incident. You want to continue on until you've explained why it made sense to the person at the time of the incident. That's the Decker principle. And remember, the reason why it made sense is going to be a systemic issue. Per Deming's principle, at least 90% of the time. So we're drilling down beyond the behavior into the systemic issues, looking for those. If that particular branch is explaining an equipment failure that affected the outcome of the incident, that we've continued on until we've identified any human organizational performance issues that resulted in the equipment failure, that we've gotten beyond the fuse failed and we've gotten into the good part, wrong application. The vendor sent us the wrong thing. We ordered the wrong thing. We designed it wrong. We're getting to the real reasons why equipment fails. We can also stop on a branch if we get to something that's totally outside the company's control. It affected the outcome, but we can't control it. We can stop on a branch if we get to something that is true, but it's not deficient in any way. Like one of the reasons you might have a spill is that you got a pressurized system, but that's a normal operating condition. But it was important to get this flow rate. And we can also stop when we run out of facts. We don't want to make things up. But the cause and effect diagram should prompt you to look beyond behaviors, look beyond symptoms that are equipment failure mechanisms to see the real reasons why they're present. Key number 4 is that HOP has to be integrated with the solution identification. And one of the things that surprised me in my travels as an analyst is, I went to a lot of training over the years, and a lot of good ways to get to causes. But when it came to the corrective actions, generally there really wasn't a process. It was kind of like chicken wire and bubble gum. It was like, Bob, what do you think? And so you need a process and tools for identifying the solutions, not just analyzing the incident. And so we at Fisher, we created this FIT's corrective action effectiveness table. And we took the U.S. Department of Energy's hierarchy of controls model that elimination is better than substitution, is better than passive engineered controls, is better than active engineered controls, is better than administrative controls, is better than PPE. And we kind of fleshed it out with some details. Now, you can't read this. In the slide deck after at the tail end, all these are broken down and explained, so you'll have access to that. But we tried to flesh out that model with some specifics. And so on the table, a 10 is the most effective type of action, a 1 is the least effective. Anything that is rated as a 1 or 2 are off the table when it comes to a long-term risk reduction measure. They don't have staying power. And often when I'm teaching this class and we start looking at what's a 1 and a 2, I get a lot of gas because people realize they've been hanging out at that 1 and 2 level with their corrective actions that they really don't have any long-term staying power. And that's why they're in Groundhog Day, and it's self-revealing to them. So 1 and 2s, no, not used for corrective actions, might be okay for a little temporary interim actions while you're waiting for your long-term actions to get implemented. But you got to have a process. And so we like to bring in not only have the team participate, but bring in the stakeholders. They're going to have to pay for this. And the frontline people are going to have to live it. And then you start going up and down each branch of your cause and effect diagram and say, what could we do here to break the chain of cause and effect? What could we do here? What could we do here? What could we do up and down each branch? And you lay out all these ideas. This was an electric shock event. There were about 25 ideas that the team came up with when we went through this with the frontline folks. And once you are done coming up with ideas of what you could do, then you go to the table and you say, okay, if we do that, would that be a 3, a 4, a 5, a 9 on the effectiveness table? Then we also assess them, and if it's a 1 and 2, it's off the table. Further consideration. Then we say, okay, if we're going to do that, what's the impact on the workers? Does it make their lives easier once they get used to it? Does it make their lives harder? Is it about a wash? Because we really want to know, what does this mean in the field? And there's been times where there's been a great idea. It sounds great to me. And then a hand goes up and it's the frontline worker that we've invited to this meeting to come up with the ideas. And they say, do you all have a clue what this means? You know, what does it mean? And you listen to them, you go, oh, that's a horrible idea. Glad I didn't come up with it. That you want those people in there, and you're hoping to walk out with the best solution set. You also can do ratings based upon relative cost, dollar values. That this information, cost isn't the consideration, but it is a consideration. You might have a more cost-effective solutions. And so this gets all the ideas out on the table, and then you do an evaluate on it. I do want to say that if you ever do go this method and you bring in the stakeholders and frontline personnel, you have to set a ground rule that I want to hear if you have concerns about the findings, but after the meeting. This meeting is given these findings, what can we come up with a solution set? If you do not set that ground rule, I guarantee you this common meeting will turn into everyone being armchair analysts, and you just spend the time kind of defending your results. Just say, I want to hear it after the meeting. But you can get some great help with this.
Rick, I just wanted to give you a 5-minute, just over 5-minute warning.
Okay, thank you. So then you narrow down that on this particular one, we took 4 to the leadership, and involving the stakeholders. They generally appreciate you involving them in the process for coming up with the solutions rather than it getting thrown over the fence. And so you may walk out of this meeting with ownership and due dates. And then key number 5 is HOP's got to be integrated with the report review approaches. And so you don't eat up the clock with sequential review. So a lot of organizations can do this. They have the team's got, you have a 30-day clock or 45-day clock that it's got to be approved. And they add several layers of review and sequence with one another. And now the team is forced to work with a much shorter clock to get the work done, and they're rushing. Also, you want to have it clear that it's okay for people in the reviewers, including your senior leaders, to question, poke, and prod, challenge findings. But changing findings is off the table. They don't get to decree what the findings are. because this makes them the analyst and undermines the entire process. Now, remember, they're going to control what we do in response to it in terms of action. They own that. But the cause determination needs to be something that's pretty sacred. We want to equip those that are actually reviewing these reports to be a good barrier against shallow analysis and ineffective fixes. And so how you do that, you need to show them what good looks like. When I was at Westinghouse, we actually had people that were going to be reviewers of reports actually have to demonstrate the ability to do a good review. So we'd have mock reports that had embedded weaknesses in there and looking for their ability to actually pick out the weaknesses. Trained those doing the reviewers on the corrective action effectiveness table, what's more effective, what's not effective, et cetera, and how to apply it, but also providing checklists that focus the reviewers on the critical to quality elements like the causes, the extent of conditions that cause corrective action program adequacy rather than cosmetic aspects. And I have seen some of these quality checklists that you could pass a root cause analysis as long as the narrative was really beautifully written, even if you got the causes of corrective actions wrong. And so you want it to drive people to focus on the right elements. And so in closing, before we get a couple minutes comments, just we give incident analysis training, mentoring, et cetera, a lot of things at Fisher, online in-person sessions available. So we do that. But I think we do have a couple minutes for questions.
Yeah, your contact information, if they want to be able to get in touch with you, it's going to be sent out as part of the summary of this with your slides and things like that. Before I get to the questions, I want to make sure that I get these announcements out for Jessica. Jessica's behind the scene. I want to say thank you. She's like the Wizard of Oz behind the green curtain, makes all of this happen. We have webinars until October of this year, and then we're going to change our format in 2026 and switch to quarterly workshops where our presenters are going to be 45 minutes of presentation and 45 minutes of engagement. That's going to be the mix. And depending on how well received they are, they may turn into presentations at the conference on the year after. Just for everybody's knowledge, the next conference is in Denver of June 22nd through 26th. So please put that on your calendars, and we're getting ready to put out the call for papers and ticketing and all that kind of stuff. Okay, I have some messages down here. Most of these are accolades. Talking about great content, and then me as a peer of yours and been a friend a long time. I really want to thank you for sharing, because that's very thought provoking. It gave people a lot to think about, especially when I first came into HOP, I didn't even know. I went to the first conference when it was HPRCT, and I had to ask, what does HOP mean? I had no idea as an RCA reliability guy what the hell HOP meant. And it really is the human side of the RCA. It's getting beyond the broken part and understanding why good people make bad decisions. So thanks for all your support and the giving people the tools they need to think deeper than why did you do that? The interrogation part. Let's see, I got two others. Is your resource on the hierarchy something you can share?
Yes. The slideshow itself, there's slides after this question slide that you're looking at that actually gets down and talks about, and let me go down there. You can see, are you able to see this?
Yes.
And it breaks it down and explains each of the columns.
Awesome.
So you'll have that.
Yeah, that's very value added, and thanks for sharing that. I know a lot of folks are so edgy about the IP, and you just want people to go out and be successful.
Exactly.
And, I encourage you all to go ahead and contact Rick directly. Last question, and we'll close it up. Is there an introduction to HOP for senior leaders who have never heard of it before?
Yes. Yeah, Fisher has a senior leader session. It's about a 4-hour session where one of the HOP specialists with Fisher, they'll come in and talk directly to your senior leaders. And again, they do it in a way that they see it for themselves. They just, it rings true. And that's where the appetite for the ugly baby comes from.
Okay, now we've learned about ugly babies. I want to go ahead and thank everyone involved, mostly for those of you that have given up your time today to come and join us and to listen to what Rick had to share with us today. So given that, I want to say thank you for supporting the coal community. And if we can answer any questions for you, please connect with us. But until then, everybody have a great week. And thanks again, Rick, for your time and for your sharing.
Certainly glad to do it. Thank you, everyone.
Take care, everybody.